morning, guys. Today we're going to be talking about how to name acids and bases. So we're going to be going over the different naming techniques or naming methods for acids. There's 3 of them. And then we're going to go over the 2 different methods for naming bases. In order to do this, we also have to learn how to name our polyatomic ions because many of our acids contain polyatomic ions. So we'll start with the acids first. They're more complicated than bases. There are 3 different methods that we use to name acids. There is the theoretical ionic name, the IUPAC name, and then the traditional name. So we'll look at the theoretical ionic name first. When you're naming an acid, it's important to remember that acids are covalent compounds. So because of that, we can name them the same way that we name normal covalent compounds. So for example, HCl would be called hydrogen chloride, HBr would be hydrogen bromide. But the theoretical ionic name takes it a step further and says that commonly we can refer to it as if it's an ionic substance, even though it's not. Because remember, hydrogen on a periodic table is over kind of with the metals because it sometimes acts like a metal. And when it is in an acid, it often acts like a metal. So because of that, sometimes we more commonly refer to acids as if they're ionic compounds. So because of that, things like HCl are named the same whether we consider them ionic or covalent. It's still just hydrogen chloride. But instead of calling H2S dihydrogen monosulfide, we just refer to it as hydrogen sulfide. So it's important when you read the name of an acid that you remember you still have to cross over your charges. There are, however, many acids that are polyatomic, which means they contain more than just 2 ions, essentially. And so we're going to be looking at how that works instead. So if you have polyatomic ions in your acid, you're going to have to use slightly different naming rules. All of the polyatomic ions that we're going to be dealing with contain an oxygen, and they are all anions, which means they're negatively charged. All polyatomic ions have a normal state, and that they can also change states where they have more or less oxygens than normal, and that will slightly change their name. So we use different prefixes and suffixes in naming polyatomic ions based on how many oxygens they have. So these are the normal state polyatomic ions that we're going to be learning about. So if we go through the list here, we've got chlorate, bromate, iodate, nitrate, sulfate, carbonate, and phosphate. As you can see, they all end with the term ate. And their name is essentially just based on whatever element they start with. So ClO3-1 is called chlorate because it starts with a chlorine. And then because it's in a normal state, it will end with ate. If you have an extra oxygen than the normal state, so if, for example, this was ClO4-1 instead of ClO3-1, then I would add the prefix per. So instead of calling this chlorate, I would call it perchlorate. If I took away an oxygen, so if I made it ClO2-1, then I would change the ate ending to an ite ending. So instead of calling this chlorate, I would call it chlorite. If I took away 2 oxygens and just made this ClO-1, then I would use the prefix hypo and the suffix ite, and instead of calling it chlorate, I would call it hypochlorite. Okay, and that same pattern is true for all of these different polyatomic ions. So if you look at this chart here, this kind of summarizes what I was just talking about. So again, our normal state is just called chlorate. Again, the chlor part of this comes from the chlorine at the beginning, and because it is normal state, it ends with ate. If I add an extra oxygen, it becomes perchlorate. If I take away an oxygen from the normal state, it becomes chlorite. If I take away 2 oxygens from the normal state, it is hypochlorite. Okay? So what I would like you guys to do is look at this chart here and see if you can fill it out following the same pattern to name the rest of these polyatomic ions. Okay, so I filled out some of it for you here. I've shown you the name of all of our just normal state polyatomic ions. So bromate, iodate, nitrate, sulfate, carbonate, and phosphate. And then I've done a couple examples for you just to double check that you're doing it right. So if I lose 1 oxygen, I go from bromate to bromite. If I have 2 less oxygen, I now am hypobromite. If I gain an oxygen from the normal state, I go from bromate to perbromate. Works the same for any of the polyatomic ions. So if we go over to sulfate, which starts off with 4 oxygens in this case, if I go down to just 3 oxygens, now it is sulfite. If I go down to 2 oxygens, it is hyposulfite. And sorry, I cannot use small or the smaller numbers. So this is SO3 minus 2 and SO2 minus 2. That 2 should be in subscript, that one should be in superscript, but I can't do that on this program. And if I gain an oxygen, so if I go from 4 to 5, so now I have SO5 minus 2, it becomes persulfate. Okay. Oh, sorry, let me get rid of my annotations here. Here we go, okay. So if you have an acid with a polyatomic ion in it and you're trying to use the theoretical ionic name, all you're going to do is say or write the word hydrogen, or the hydrogen that's at the beginning of all acids, and then name whatever the polyatomic ion is. So for example, if you add H2SO4, we write hydrogen to represent the H at the beginning, and then SO4 is a sulfate ion because SO4 is the normal state of that polyatomic ion. And then don't forget, we always cross our charges, which is why in this case there is 2 H's, because the sulfate ion has a charge of 2. That's going to cross over there. So once again, when you're writing any formula for an acid, always cross your charges. If I instead had H2SO3, I now have a sulfate with 1 less oxygen than normal, so that is a sulfite ion, and so I would call that hydrogen sulfite. It is important to note that you guys do have to have those names memorized, so pretty much anything that shows up on this chart, or once that chart's filled in, what shows up on it, you do have to have memorized, okay? And I will show you the way I memorize it. Yeah, just so you know, next year, this isn't something that you have to have memorized. It is in the Chem 30 data booklet. So for some reason, it's only this year that they make you memorize this stuff, but I will show you the way that I memorize it, just to kind of help you remember it.
Okay, so the way I memorize my polyatomic ions is something I call C-bins CP. C-bins CP, where this is chlorine and that's carbon. So what I have here is my chlorate, bromate, iodate, nitrate, sulfate, carbonate, and phosphate. C-bins CP. 1, 1, 1, 1, 2, 2, 3, 3, 3, 3, 3, 4, 3, 4. And what this represents is this is the charge, which never changes for a polyatomic ion. And then this is the number of oxygen molecules at normal state. So I know if I memorize CBINS CP 1111222333333434, if I'm asked what a sulfate ion looks like, I know that it's SO4 minus 2, because my sulfate has a charge of 2. These are always negative, by the way, and it has 4 oxygen. If I'm asked what a phosphite would look like, well, I've got my P right here. I know it's going to have some O's. Its charge is always -3. And I know in the normal state, it has 4 oxygens. And ite ending means 1 less oxygen if the ite ending is all that's different. And so instead of having 4 oxygens, I will have 3. Okay, so that's the way I memorize it. You can do it however you want, but I just thought I would share that with you. Whenever I was writing a test or anything like that, I would always write this out at the top of my page. Okay, so that is how we do the ionic or theoretical ionic naming of acids. Again, you just name it as if it's an ionic compound. So say hydrogen at the front, because there's always going to be a hydrogen at the front of your acid, and then name whatever the other ion is. So if it's a chlorine ion, then it's hydrogen chloride. If it's a sulfate ion, then it's hydrogen sulfate. Okay. The IUPAC naming is almost identical to the theoretical ionic name. You just write the word aqueous in front. So HCl would be aqueous hydrogen chloride instead of just hydrogen chloride. If I had HClO3, it would be aqueous hydrogen chlorate. If I was using the theoretical ionic name, it would just be hydrogen chlorate. So all I'm doing is taking the theoretical ionic name and adding the word aqueous in front. That is it. So pause now, see if you can figure out what these last 2 names will be, and then unpause and I will tell you what they are. Okay, so HClO is missing 2 oxygen from its normal state. And so I would call this aqueous hydrogen hypochlorite, because ClO as an ion is hypochlorite. So aqueous hydrogen hypochlorite is the answer there. And then for HClO4, the ClO4 has 1 extra oxygen than normal. So that is a perchlorate ion. So this would be aqueous hydrogen perchlorate. And I will write those out for you. Okay, so that's what the names would look like. Again, the hypochlorite comes from the fact that this ClO has lost 2 oxygen compared to the normal state. And then for this one, aqueous hydrogen perchlorate, the perchlorate comes from the fact that it has an extra oxygen compared to the normal state. Okay, and then the last type of naming for acids is called the traditional naming of acids. When we're using the traditional name of acids, we don't use the word hydrogen like we do in the 2 previous naming systems. And all of the acids end with the word acid. If you have an acid that contains a polyatomic ion, it will use the prefix hydro, and then the ending gets changed to ic. Okay. So sorry, that's if there's no polyatomic ion, it starts with hydro. So for example, HCl, there's no polyatomic ion there. We can tell because there's no oxygen. So as soon as there's no oxygen there, it's not polyatomic, we use the prefix hydro, the ending gets changed to ic, and then there's always that word acid at the very end. So HCl is hydrochloric acid. Hydro to represent the H, chloric to represent the chlorine, and then traditional names always end with acid. HBr is hydrobromic acid. Pause for a second and see if you can figure out what HF is. It would be, once again, hydro for the H, fluoric for the F, so hydrofluoric acid. Okay. If you do have a polyatomic ion, you're going to change the prefixes and suffixes based on how many oxygens there are, whether it's normal state or has extra or fewer oxygens. The other special thing with polyatomic ion acids is that you don't use the prefix hydro anymore. So we only use the term hydro in traditional naming if it's not polyatomic. Okay? We do still change the ending to ic if it is a normal state polyatomic ion, and as with all traditional names, it will always end with acid. So HClO3, again, we're not using the prefix hydro, so we actually don't use anything to show that there's an H at the front of this. We just assume that because it's an acid, there must be an H at the front. So we don't have anything to denote that H being there. Because this is a chlorate ion, we have that chlor as part of the name, and then the ending gets changed to ic because chlorate is a normal state polyatomic ion. So this would be chloric acid. If I have an extra oxygen, so instead of having a chlorate ion, I have a perchlorate ion, then I call this perchloric acid. Okay, still have the ic ending, but I'm now using that prefix per to show that I have an extra oxygen. If I have one fewer oxygen than normal, then I'm going to change the ending to OUS instead of ic. So in HClO2, I have one less oxygen than normal on my chlorite ion. So this becomes chlorous acid. Again, still nothing to show that there's an H there, not using hydro because it's polyatomic. So chlorous acid. And if I am down 2 oxygens from my normal state, it becomes hypochlorous acid. Okay, so try and fill out this chart, and I'll also fill out part of it to kind of show you what this is going to look like. Okay, to just kind of show you what this would look like for our SO4, our sulfate ion. So I started by going through and writing out what our sulfate ion looks like when it's not in its normal state. So if it loses an oxygen, it's SO3 minus 2, loses 2 oxygens, it's SO2 minus 2. Again, sorry that I can't show the 2 drop down and the minus 2 up high. And then if it has 1 extra oxygen, it's SO5 minus 2. I then went through and named these different polyatomic ions. So again, it's called sulfate when it's in its normal state, sulfite if it's down an oxygen, hyposulfite if it's down 2 oxygens, and persulfate if it has an extra oxygen. I then went through and wrote what the acid formulas would look like for this. You can see that all of them start with H2, and that's because all of the ions have a charge of -2 that crosses over. The only thing that's changing is the number of oxygens on our sulfate ion. So sulfate has 4 oxygens, sulfite has 3, hyposulfite has 2, etc. For the theoretical ionic name, we always start with the word hydrogen and then just write the name of our polyatomic ion. So H2SO4 would be hydrogen sulfate, H2SO3, hydrogen sulfite. Okay. I didn't bother filling in this whole category because essentially all you do for the IUPAC name is take the theoretical ionic name and write the word aqueous in front. So instead of hydrogen sulfate, we have aqueous hydrogen sulfate. Okay. This one would be aqueous hydrogen sulfite. And then the one that's most different is the traditional name of our acid. So if it is in normal state, if our polyatomic acid is in the normal state, we drop any prefixes. We don't use the word hydrogen or hydro. We change the ending to ic, and we always have that word acid at the end. So H2SO4 would be sulfuric acid. If we have an ite ending instead of an ate ending for our polyatomic ion, that ic becomes OUS. So ate, ate goes with ic. Ite goes with us. So hydrogen sulfite is called sulfurous acid. Hydrogen sulfate is sulfuric acid. And then if you have a polyatomic ion that has one of those extra prefixes in front, like hypo or per, those stay when we do the traditional naming. So hydrogen hyposulfite becomes hyposulfurous acid. Again, the ite ending in a theoretical name goes with an OUS ending in a traditional name. So hyposulfurous acid. Hydrogen persulfate becomes persulfuric acid. Again, an ate ending in the in the theoretical name goes with an ic ending in the traditional name. But once again, none of these traditional names for our polyatomic acids have the word hydrogen or hydro in front. We only see the word hydro in a traditional name if it's a non-polyatomic acid, like what we have at the bottom here. So H2S is not polyatomic. It's just called hydrogen sulfide. We still use our IDE ending if it's not polyatomic. The IUPAC name would be aqueous hydrogen sulfide. And then because it's not polyatomic, we use hydro as our prefix. It is sulfuric because of the sulfur, so hydrosulfuric acid. Okay, a lot of different naming rules to memorize there. Try filling out this chart with a different polyatomic ion, like the bromate one here, for instance. Okay, so that's it for the acids. Next up is the bases, which is much easier to name than our acids. There's really two naming systems that we're going to go over. We're going to look at the classic naming, but only for a few bases, and then the IUPAC naming for most of the rest of them. These naming systems do work mainly for our bases that end with OH, which most of our bases do. Okay. The only base that you have to memorize that is not going to fit these naming rules that we talk about right now is the one at the very bottom here, ammonia. So you do have to know that NH3 is ammonia and that it is a base. So we'll go through the IUPAC naming first. It's super easy. Essentially, we are just going to name these bases like normal ionic compounds. Most bases are ionic compounds. They're usually made of a metal and then the hydroxide ion, which is the OH. So all we do is write the name of the metal first and then the word hydroxide to represent our OH. So for example, NaOH is just sodium hydroxide. Calcium hydroxide is CaOH2. So don't forget, just like with all ionic compounds, when we go from a name to a formula, like with calcium hydroxide here, we have to cross over our charges. So calcium has a charge of 2, we cross that over, and because that 2 is applying to the entire OH, the entire hydroxide, and not just the hydrogen, we have to put the hydroxide in brackets to show that. Okay, so that's really important. So take a second now and see if you can figure out what the name of KOH is and what the formula for lithium hydroxide and magnesium hydroxide would be. Okay, so this is what your answer should be. KOH is potassium hydroxide, potassium for the K, hydroxide for the OH. Lithium hydroxide is LiOH, and magnesium hydroxide is MgOH2. Again, that 2 should be in subscript. This one has a 2 here because magnesium has a charge of 2, and we have crossed our charges. So you will have some bases that include one of those transition metals, which can be multivalent. Those are the ones in the drop-down section that we don't know the charge of. So in this case, when you're writing the name of that base, you do have to include the charge of your transition metal in Roman numerals in brackets, just like how we practiced last year when you had to write the charge in brackets for any ionic compound that included one of those multivalent metals. So for instance, if I have iron 2 hydroxide, this 2 in Roman numerals here tells me what the charge of my iron is. So iron is Fe, hydroxide is OH, and then I cross this charge of 2 over. So try and figure out what the formula for the base would be if I had copper plus 2 with hydroxide or copper plus 1 with hydroxide. Okay, these should be your answers down here respectively. So if my copper has a charge of plus 2, it gets crossed over. If it is a charge of plus 1, I don't have anything crossed over. The name for this first one here would be copper 2 hydroxide, and this one would be copper 1 hydroxide. So even though it has a charge of 1, when we're writing our Roman numerals, you still have to include it. Okay, so that's what those 2 names should look like there, copper 2 hydroxide and copper 1 hydroxide. Because copper is a transition metal, we have to show its charge. Okay, and then the last type of naming that we have is classic naming. We're only going to learn the classic naming for 3 different metals. Essentially, we're going to do this for iron, copper, and lead. Both of those, or all 3 of those metals, have a 2 fairly common charges. One is higher, one is lower. The higher one will have the ending of ic. The lower one will have the ending of OUS when it is combined with an hydroxide. So for instance, iron, its Latin name is ferrum, which is where the Fe comes from, and its 2 most common charges are plus 2 and plus 3. So that would be FeOH2 and FeOH3 respectively. FeOH2 is the one with the lower charge because 2 is lower than 3. So it gets the ending OUS. So FeOH2 would be ferrous hydroxide. As you can see, its name is based on its Latin name. So instead of ferrum, it is ferrous to represent its lowest charge. We still have hydroxide to represent the OH. FeOH3, that's the one with the higher charge, still has that kind of ferrum root, but its ending is going to be changed to ic. So ferric hydroxide represents that it is the iron with the higher charge. The Latin name for copper is cuprum. The Latin name for lead is plumbum. So I would like you guys to try and write the names for all 4 of those bases listed at the bottom there. Okay, so these are the answers that you should have got. So if we compare our 2 coppers here, the one on the top has the lower charge, 2 is higher than 1. So we start with copper, which is cuprum, and then because it's lower charge, its ending gets changed to OUS, so cuprous, and then hydroxide to represent the OH. With the one with the higher charge, the ending gets changed to ic instead, so cupric hydroxide. With our lead hydroxides, again, the lower charge is going to have the OUS ending, the higher charge has the ic ending. we start with our Latin name plumbum, and then the lower charge ends up as plumbus hydroxide, the higher charge as plumbic hydroxide. So I know that that was a lot to take in. There's a ton of different naming rules. Go over it, start practicing it, fill out those charts that are in this slideshow for a bunch of different of the polyatomic acids and the normal acids.